Hello everyone, my name is Adarsh Raghav and I am a third year student of CSE at Bennett University, and today I will be giving you a seminar on a topic called green cloud computing. Now, before we understand the concept of green cloud computing, we need to understand the term which is after green called cloud computing. It is important for you to understand what cloud computing is because it is the base of on which green cloud computing lies. Now, cloud computing, when simply put, is basically the on demand availability of computing resources as services over the internet. So, cloud computing as a whole is basically servers, racks, and rails. And cloud service providers are the ones that own data centers and have these servers put online. And you can do various tasks on them. And these tasks are basically called services. Now, these services, I'll give you a few examples of the services that cloud computing really provides. And these services could be like VMs, virtual machines, where you're basically virtualizing the operating system and the hardware, and you can use it anywhere around the world with a high performance and availability and throughput. And the next service you can use is storage to keep all your data, documents, etc., anything that the client owns. Next, it could be content delivery. Now, since cloud data centers are all around the world in every country, multiple states in a particular country, you can deliver content such as videos, images, or maybe games around the world with high availability, of course. The other service that cloud computing provides is analytics. So you can run analytics over your data or maybe anything that you're producing in form of numerics or images, anything in analytics or data is just one example of it. And the other service, another example of a service is container management. So you can basically create containers and you can manage containers um, basically using Kubernetes, which is a very famous container orchestration service, or you could use Docker again, which is very famous as well. Now, before we continue further, it is important to basically understand the good and the bad of cloud computing itself. So, firstly, I'll be talking about the good or the advantages of cloud computing, and starting over the first point, which is basically they promote capital expenses over variable expenses. So, what does that basically mean? So, in previous times when cloud computing or CSPs weren't such a large scene as a whole, people used to own their own servers, racks, rails in form of data centers. So they created a whole data center and they had servers and racks and rails, which costed them a significant amount of money. Now, with the introduction of CSPs or cloud providers, this cost had been reduced down because of variable expenses since you're renting out the resource. Now, the cloud service provider is the one who owns the data center, the servers, the racks, and the rails, and all of this becomes a variable expense because of the pay as you go model. The next advantage of this of cloud computing is that increased speed and agility. Now, again, back in the old days when we had our own servers and racks, we used to own them ourselves. It was very difficult to set up and buy more space because that costed more. So you had to expand and all. But because of this becoming an online system where you're purchasing through a third party who owns all the data and you more data centers and servers, and you're basically renting them out for a significant amount of time, you're getting more performance for lower cost. So that increases speed and agility itself. And since these data centers are always improving on themselves, so they bring in new technology in these servers and optimization as well. The third advantage is going global in minutes. So, as mentioned early in the previous points, you're basically renting out resources, right? So, servers are already initialized for you, and you're just renting them out. So, whenever you put in a request, the server's already ready and ready to go. So, basically, going global in minutes. Now, if we were talk about the fourth point, which is economies of scale, this is that since there's a pay to go model, which means that you're only paying for the amount you're using, you're paying significantly less for higher performance. So the basic model of cloud computing is that you pay less without compromising on performance. So that is another advantage of cloud computing. Now, if you were to talk about the bad or the disadvantage of cloud computing, it is that it produces a lot of carbon emission or carbon dioxide, which leads to greenhouse gases, which in turn leads to climate change. Now, in a study that was conducted by the International Energy Agency in 2020, 31.5 gigaton of carbon dioxide was emitted around the world. Now, that could be anything like industries, factories, cars, everything included was 31.5 gigatons. And 0.3% of this carbon emission was from data centers itself. So these could be data centers by Azure, AWS, GCP, Oracle, anything. So 0.3 was contributed from data centers itself. And now this may seem like a small amount because it's been converted to percentages, but when you think of it or calculate it numerically, 0.3% over 35 gigaton is a very large amount. And this is one of the bigger advantages of cloud computing, since you have one concentration of data centers where you have a lot of carbon dioxide emission. So the main question that arises here is that what is basically green cloud computing and how does it fit into the picture here? So to talk about it, we need to understand the goals of green cloud computing first. First and foremost goal that has been internationally recognized is that we need to construct green data centers. What does green data centers mean? Now, green data centers is basically reducing the impact on the environment and basically reducing your carbon emissions. This can be done in various ways. For instance, using efficient lighting or maybe efficient energy appliances and using renewable energy instead of non-renewable energy. The next goal or the second goal was to recycle and reuse waste. Now, the waste that has been maybe created from data centers itself can be reused. For instance, if you have old servers that you need to put down, you can dismantle them and take out parts that can be maybe used in newer versions of the server itself. The third goal of this of green cloud computing is increasing energy efficiency by reducing data center consumption. Now, again, like I mentioned in the first point, you need to use energy efficient appliances. That could be lighting itself, where you have automated lighting when there is no manpower or maybe no human inside the data center or a particular section of the data center. You switch off the lights, basically motion sensing lights, and you could basically perform DVFS, where you're basically decreasing or increasing or fluctuating the voltage of the appliance as per the need. And the fourth or most important goal of green cloud computing is reducing hazardous materials. Sorry. Now, material could be in while the construction of the data center, or maybe the appliances itself. We're using environmental friendly approaches to maybe maximize the efficiency of the data center without compromising on environment by using more healthy material or anything that is being used in construction or appliance or management or day-to-day tasks. Now, since I've already mentioned the goals, it is also important to understand how we can actually achieve green cloud computing. How is it possible to achieve green cloud computing? So mainly three ways to achieve green cloud computing. So I'll go to the first point, which is virtualization. Now, don't confuse yourself with the virtualization in maybe operating systems or hardware, which can be done using virtual machine and containers. But this is a different type of virtualization where you're sharing one single instance with multiple customers. So you have a server and you have multiple customers who are using that particular server or maybe service itself. So that is basically reducing the impact on the environment by making more people use the same appliance, and the same appliance will always release or give out the same amount of carbon dioxide or emission if it were used by one person or maybe more. But a disadvantage of this process or this approach is that there'll be various clients who would have compliance issues where they might not be willing to share their servers or a particular server with multiple users due to privacy or data concerns. So that is one big advantage of this approach. Now, the second approach is dynamic voltage frequency scaling. And this is one of the most well-known, well-used services in today's time in the cloud industry, where you're basically reducing and increasing, basically you're fluctuating the power that is being provided to the CPU or the appliance such as a server dynamically based on the consumption needs of the client. So let's say if you're using lower, if you have a lower demand, reducing voltage, and if you have a higher demand, you're increasing voltage. Now the difference is very visible in a graph you can see below, and here you can see if you had a fixed voltage, consumption would increase exponentially. But if you had a variable VDD or variable voltage, you'd have higher power savings, as the difference is visible in the graph, in the two graphs itself. Now, the third approach, which is still developing and not prominent in today's world, because still in the development phase, is nano data centers. Now, nano data centers, the name itself suggests that you have a smaller number of data centers, and you basically, when compared to a significant normal data center, which is humongous and has a lot of servers and server spaces, nano data center is very small. And as you can guess by itself, that a nano data center will have a lesser amount of emission, lesser requirement of energy and heat dissipation, right? So the cost of heat dissipation decreases, you're taking in less electricity and releasing lesser amounts of carbon dioxide. Now, a few other advantages of this are there's high service proximity and high scalability. So you're still getting the same performance with nano data centers in a small compact unit, and you can have more number of nano data centers and more availability zones as compared to a normal data center, which will be one large data center in lesser number of regions. Now, I'd like you to go through a case study with me. This is a case study of the Google Cloud Platform, or GCP, and this is some of the data that has been provided on their website and white papers. And to basically make you go through the points, the first point is that in a study conducted by themselves, when they did their sustainable study, 81% of they figured out that 81% of the waste was diverted from landfills. So what this basically means is that prior, 81% of the waste that were to go to landfills has been reused or recycled in some way to be reused again in form of energy or any sort of appliance. The second point is that 100% of the renewable, 100% of renewable energy is being used in cloud regions. So basically, what this means is that regions all around the globe, all around the world, all GCP regions or data centers are using 100% renewable energy. So there's no use of fossil fuels or non-renewable energy, which is a significant impact when you compare it to a standard data center, which is maybe using fossil fuel or traditional electric lines and producing carbon emission. Now, an interesting find of this research was that with the implementation of all of this sustainable management and 81% of diversion of waste from landfills and 100% using of renewable energy resulted in 2 times the performance of a typical data center. So as compared to a data center that was previously being run, how it was previously being run, the data center now is giving 2 times more performance or higher performance. Now, to validate the claims itself, a PUE study or a power usage effectiveness study was done, and a score of 1.1 was given, which is very high compared to traditional data centers. So thank you all of you for your time. And this was a brief introduction or a brief description of what green cloud computing really is and how we can achieve it. Thank you.